Assalamualaikum and good day to everyone. Now we continue our new objective for the lecture, Kinetic, which is objective number 4, to describe the kinetic of a particle motion by resolve into rectangular coordinate. And then number 5, to describe the kinetic of particle motion along a non-curved path by resolve into normal and tangential coordinate. So we're going to study what is the rectangular coordinate and then normal and tangent coordinate. Next, equations of motion, rectangular coordinate. First, the equations of motion F is equal to MA is best used when the problem requires to finding forces, especially forces perpendicular to the path, and to determine the acceleration, velocity or mass. So you must remember here, unbalanced forces cause the acceleration. So number 2, we have 3 scalar equation can be written from the vector equation. So the equations of motion, being a vector equation, may be expressed in terms of 3 component Cartesian, or we call it rectangular coordinate. So number 1 here, from the summation F is equal to MA, so we can have it. What is the summation F? So summation F in rectangular coordinate, we're going to have summation Fx in X, summation Fy in Y, summation Fz in Z axis. So we can have here I, J and K. So for the kinetic, we're going to have MEX, MEX plus MEY plus MEZ. So when we divide into scalar equation, so we have summation Fx equal to MEX, summation Fy is equal to MEY, and summation Fz is equal to MEZ. So here, this kinetic is depends to the motion. So if you have a motion in AX, then you have the MEX. If you don't have motion in Y or in Z, you just have 0. Okay, understand? Alright, so why we need to study these equations of motion? How you going to apply this one? So let's say you have a man is trying to move a 100-pound crate. How large a force F must be exerted to start moving? And then what is the influence factors to moving the crate? And then if the crate start moving, is the acceleration. So you can calculate by using the equation F is equal to ME. And then now what is the step for analysis? So as a previous lecture, we have 4 steps, right? So number 1, we need to establish the initial coordinate. So now we have rectangular X, Y, Z. And then number 2, you need to draw the free body diagram to show all the external forces. So what is the external forces? You have the weight, normal force, friction force and applied force. And also you have the spring, right? And also spring. And then you must remember, friction force must acting opposite to the direction. And then you need to sketch the kinetic diagram to show the particle initial, which is the MA. And then you can apply the equations of motion according to the axis. So any kinematic relation, you can have the kinematic equation. Alright, so next example 9.3. So here we have the motor wings in the cable with a constant acceleration such that 20 kg crate move a distance s is equal to 6 meter in 3 seconds, starting from the rest. So given mu k is 0.3, determine the tension developed in the cable. So now the question asks to determine the tension here. So this is the tension. So how are you going to get this tension? By using this F is equal to MA. So definitely step 1, we need to establish the coordinate system. And then step 2, to draw the free body diagram to show all the external forces, and then to draw the kinetic diagram to show the direction of the moving. Okay, and then step 3, you can use the equation of motion and then or any kinematic equation to solve the tension in cable. Can you do that? Okay, so here next, so here we can draw the free body diagram. So for this example, so you can use the incline as a x and y. So you can sketch x and y. So you can follow the incline axis. So the incline axis is x and then the other direction is y. So first, we need to sketch the free body diagram for the particle. Okay, for the crate. So now we have external force. What? We have weight. So this is weight. So mg20g. And then what we have? We have tension in cable, T. And then we have normal force perpendicular to the surface. And then we have the friction force. So must remember, friction force acting opposite to the direction. So this is the direction. So friction force is here. So friction force is equal to mu n. So this is the mu kn. So mu n. So for this case, you need to determine what is the n value. Right. What is the n value? Because the mu k is given 0.3. So this one is equal to ma. So this is kinetic. So the kinetic moving to the right, 20a, ma here. Right. So this is the free body diagram. Okay, next. How to use the F is equal to ma to get the tension. So now we need to determine any variable, that any information that we can have. So based on this question, so we need to determine what is the A, because we want to use F is equal to ma. So M we have here, so A we need to determine by using the kinematic equation, because the question have give us the S and then T, and then we have the initial velocity is equal to 0. So you can use the Suvat equation. So you can substitute S is equal to 6, V initial V is equal to 0, and then T is equal to 3, and then here we want to have A. So you can solve the equation. So you will get the A is 1.33 meter per second square. So we can substitute into the equation. So now we have divided the summation F is equal to ma into summation Fy and summation Fx. So for this case, do we have the moving in vertical? No, right? So we can have here summation Fy is equal to 0. So you must resolve all the force in y direction. For this case, we have weight, right? Weight and normal force. So that is why we have summation Fy is equal to 0 is equal to negative 20g times cos 30, because we have the incline here is 30 degree. So plus n. So we can have here n is equal to 169.9 n. So why we need to get the n? Because we want to substitute into the friction force. Right. So now, how to solve the tension here? So the tension here is summation Fx equal to ma. So now you have the A already. So you can have the summation Fx. So you look into x direction. So you resolve all the force in x direction. So in x direction, we have t minus 20g sine 30 minus Fk. So what is the Fk? Fk is 0.3 n. So you can substitute the n here. So it's equal to ma. M is 20. So A is 1.33. So you substitute everything, then you can solve it. So you get the t equal to 176 Newton. Next, example 9.4. So here we have 300 kg bar B originate at rest is thrown over a series of small rollers. The motor M is drawing in the cable at the rate V is equal to 0.4 T squared. So determine force in the cable. So as usual, we need to determine the force in the cable and distance S. So we need to get what is the distance S when T is equal to 5 seconds. So as usual, you have 4 steps. What is the step number 1? So step number 1, we need to sketch the coordinate. So we have here X and Y. And then we need to draw the free body diagram and kinetic diagram. So here, what is the force involved? What is the external force? So here we have the W is equal to mg, and then you have the normal force, and you have the tension in cable. So it's equal to this direction, right direction, MA 300 and 300A. Okay, so next you need to apply the equation of motion. So equation of motion in x direction, you have what? You have the direction in x, right? So you have summation fx equal to mex. So what is the force in x? So we have T here, right? So summation fx is equal to 300 MA. So summation f, we have the T. We have T only, right? So we can have here T is equal to 300A. So how we going to substitute A? Okay, so now A can be derived from the V. So V is given 0.4 T squared. So we understood that when we differentiate V, we can get the A. So we can differentiate the 0.4 T squared. So we differentiate A is equal to dv dt. So we get 0.8 T. So T is given 5 seconds. So you can substitute here 0.8. So you have T is equal to 300 times 0.8 is 240 T, right? So you can substitute T. T is equal to 5 seconds. So T is, so the tension in cable is 1200 when T is equal to 5 seconds. Easy, right? Okay, next, we need to determine what is the distance. Distance is S. So, similar equation given V is equal to 0.4 T squared. So, to get at A, we need to differentiate. So, to get the S position, we need to differentiate or integrate. Integrate, right? So, we integrate the V 0.4 T squared. So, we become, what is the S? So, you get the S is equal to, when you integrate 0.t squared, you get the 0.4 divided by 3t to the power of 3. So, you substitute T is equal to 5 seconds. So, you can obtain S is equal to 60.7 meter. Next, 9.4 equations of motion, normal and tangential coordinate. So, you refer to this figure. So, we have the particle here. So, when a particle moves along a curved path, it may be convenient to write in normal and tangent coordinate. So, here you can have, as usual, tangent to the curve is the T. And then, perpendicular to the T is the N, which is N is always to center of curvature. So, means that this is the curve. So, this is the curve. So, the center of curvature is here. So, always normal is always point toward the part of the center of curvature. So in circle, the center of curvature is the point, is the circle point in the middle point, right? Okay, so here, when we have tangent to the part, we set is a positive. Okay, set as a positive direction motions of the particle. And then when we have the tangent here and normal here, so in between that, we have the binomial. Okay, so we have the equation here. In tangent, we have the summation f tangent is equal to u tangent, summation fb is equal to ub, and then we have here summation fs equal to un normal. Alright? Okay. So, when we have, since we have the equations of motion, summation f is equal to ma, so we can write in terms of normal and tangent, we become like this. So, we have the summation of tangent plus summation of normal plus summation of binomial is equal to mat plus man. So, now, there is no motion in binomial direction, so we can write summations of fb is equal to 0. Alright. Okay, so here when we involve normal and tangent coordinate, you need to understood that the tangent acceleration is equal to dv over dt, represent the time rate of change in magnitude of velocity. Okay, and then normal acceleration is given by the formula, which is v squared over rho. So now, if rho is not be given, so you can use this formula, this rho. So you can have, you need to have the parts of motion. So you have first derivation and second derivation. So substitute the formula. So this is the application that why we need to resolve into normal and tangent, because let's say we have the track here, we need to reduce the friction force required keep the car from sliding up to outer rail at high speed, and also we can calculate the maximum velocity and also the friction between the tire and also the minimum angle to prevent the car from the sliding up the track. And then the next application, we can study, we can get the velocity of these cars at A and B, right? Okay, and then next application is, let's say we have satellite here held in orbit around the earth by using the gravity, and then we want to calculate what is the speed of this satellite. Okay, alright, so this is the step for analysis for the normal and tangent coordinate. As usual, first you need to establish the normal tangent coordinate. So you must remember the curved part is the tangent positive, and then towards to the curvature is the normal tangent positive. And then step 2, you need to sketch the free body diagram and kinetic diagram. Alright, so must remember normal acceleration an, okay, positive in towards the circle, and then the tangent acceleration at must be positive or negative, depends on the curved part, where is the moving part. And then the third one, you can apply the equations of motion. And then the fourth one depends on the equation that you can use the kinematic relation. Okay, now next is example 9.5. So here we have 10 kg ball as a velocity of 3 meter per second when it is at A along the vertical part. So determine the tension in the cord and the increase in the speed of the ball. So now you need to calculate what is the tension in the cord, and you need to get what is the V here. So how many steps do you have? You have 4 steps. So this is, you need to establish the normal and tangent, right? And then you need to sketch the free body diagram. So this is the tangent, right? And then this is the normal. That is the first thing that you must know how to do that. Alright. So So you establish the normal and tangent. First you need to sketch tangent. So this is the directions of the particle kan, moving the particle here. So here this is the free body diagram. So this is your tangent, positive. So perpendicular to tangent is normal. So this is normal. So what is the force, external force acting here? So for this case, you only have the W. W is equal to mg. Alright? Okay. So kinetic diagram you have. So if towards the T here, you have the MAT, a tangent, and normal here, you have MAN, a normal. So after you have the free body diagram, then you can apply the equations of motion. So now what is this 2 meter? 2 meter is rho. Okay. Alright, so we step 3 we can apply the equations of motion n and t. So here you must resolve in summation of n coordinates. So summation fn is equal to man. So what is the force in normal axis? So we have t minus w sine 45 degree is equal to man. So now we need to calculate what is the an. So an here is v squared divided by rho. So what is the v squared? V squared is given 3. So 3 squared divided by 2. So we have w here. W is mg, 10 times 9.81. And then you can solve. So by using this, by substitute this equation, you can solve T is equal to 140 Newton. Okay, so now next we need to get what is the speed. What is the increasing speed, right? So here we can use the summation tangent is equal to MAT. So what is the force in the tangent? So you have W cos 45 is equal to MAT. So now M is 10. So this is the W. That 98.1 cos 45 is equal to 80. So you can have here. You can differentiate here you can differentiate V to get the 80. So 80 is equal to 6.94. Next, example 9.6, we have the boy has a weight of 16 pounds. At the instant theta is equal to 60, the boy's center of mass G experiences speed V 15 feet per second. Determine the tension in each of the two supporting cords of the swing and the rate increase in his speed at this instant. So now we need to get what is the tension. So you have 2T here because 2 supporting swing. So you need to, okay, you have 4 steps. The first step, you need to know what is the normal and tangent. So for this case, this is the direction, right? So this is the tangent. So towards center here, this is the normal. So can you sketch that? Okay, now this is the free body diagram to show the external force. So this is the tangent axis. So tangent axis. So this is the normal. So the normal here we have tension 2D. So what is the external force we have? We have the weight. And then don't forget the angle 60 degrees. So the weight is, so now we have what is the system unit. So system unit here is the FPS, right? So what happened to the W? W is base unit or derived unit here. You must remember. Okay, so now we have the kinetic diagram. So the kinetic diagram here we have MAT here, and then here we have MAN. So now you can use the equations of motion, right? So you have rho? Yes, right. The rho is given. Okay, so now the equations of motion, So you resolve into normal and tangent. So number one, you must resolve all the force in normal. So F summation Fs equal to MEN is equal to 2t minus W sin 60 is equal to MEN. So now you need to calculate what is this MEN. So AN is equal to V square over rho. So V square is given, rho is also given. So you can get T is equal to 49.6 pound. So here in FPS unit, V is given as the base unit. So if base unit, you can directly use, right? No need to W is equal to mg. So this one is SI unit. Alright. So next, we need to get what is the speed, right? So we use the summation Ft is equal to MAT. So we need to resolve all the external force in Ft. So here we have W 60 cos 60 is equal to MAT. So now we need to get what is the M. So M is equal to WG. That is why here in the FPS unit, you need to divide the W60 divided by 32.280. So AT is equal to V is equal to 60.1 feet per second square. Understand? Next, example 9.7. So we have a 800 kg car is travelling over a hill with the shape of parabola. When the car is at point A, its V is equal to 9 meter per second and A is 3 meter per second square. So neglect the size of the car. Determine the resultant normal force. Resultant normal force is what? N, right? And resultant friction force. So friction force kinetic exert on the road at point A by the car. So now what is the first step? So first step, we need to sketch the what? The axis, right? Normal and tangent. Okay, second, you need to sketch the free body diagram and then kinetic diagram. And then the next step, you need to apply the equations of motion. So now okay, so this is the, where is the motion? This is the motion, right? So this is the T and the curve. This is the curve. So towards it, the normal. So here is given the curve part is y is equal to 20 minus 1 minus x squared divided by 6,400. So that means that you're going to differentiate first dy dx, and then second you need to differentiate dy dx square, right? To get what is the rho, because the rho is not be given. Okay, next. So now we sketch the free body diagrams, normal and tangent coordinate. So for this case, so this is your particle. So your particle, this is the normal. This is first, this is the tangent, and this is the normal. So now you have, this is the n. So you need to calculate the n, right? So you also have the weight here. Okay, and then you have the friction. This is the friction. So the friction must be what? Opposite direction to the car. So this is the moving car. This is the friction. K. Okay. So it's equal to MAN, MAT. So this is the MAN and this is the MAT. So you're going to solve summation Fn is equal to MAN, summation Ft is equal to MAT. So the question asks us to get what is the N, normal force on the road. So how to do that? Okay, first we need to apply the normal tangent. So first summation Fn is equal to MEN. So what is the force in normal direction? So we have W cos theta minus N is equal to MEN. So now do we know the theta? The theta is not be given, right? So we need to calculate. So here, can we calculate what is the AN? Can, right? So AN is equal to V squared over rho. So now you need to calculate what is the rho. Okay. So now to calculate the rho, so you just have the equation in rho. So now you substitute everything. W is equal to mg and then AN. So here we have 800. M is 800, 9.81. Cos theta minus N is equal to 881 over rho. So you can have N here. So you arrange the equation and then this is the N. So N is equal to 7,848 cos theta minus 64,800 divided by P become equation 1. And then you use the second equation, Ft is equal to MAT. So resolve all the force in tension. So we get W sin theta minus F is equal to MAT. F is the Fk. So here, as usual, W is 800, 9.1 sin theta minus Fk, and then MAT. So this is the M, and then this is the AT. Right, AT is given 3. Right, so you have the force here, F is equal to 7,848 sin theta minus 2,400 become the equation 2. So next, the question given the part y is equal to 20, 1 minus x squared 6,400, and also given x is equal to 80 meter. So now you need to get what is the first differentiate and what is the second differentiate. So you have here, you substitute the value x is equal to 80, then you can have this is the 0.5 and this is the 0.0625. So you can substitute into rho equation, then you get the rho is 223.6 meter. And then how to determine the angle? So from the slope given at A, you can have tangent. So you must remember tangent theta is equal to dy dx. So you have already, right, dy dx, right? Here, negative 0.5. So theta is equal to shift tangent negative 0.5. So you have theta is equal to 26.6. So this one you can substitute into the equation 1 and equation 2. So here you can have normal force is equal to 6,728 Newton, and then you have the friction force is equal to 1,140. Alright, that's all for today. Hope you can achieve the outcome of the lecture, which is to describe the kinetic of particle motion by resolve into rectangular coordinate, and then to describe the kinetic of particle motion along curved path by resolve normal and tangent coordinate. So don't forget to do the tutorial and answer the pop quiz. See you for the next lecture. Bye.